So this video lesson is all about something that we call simple interest. And now that we've gone through proportions, percents, we've looked at some applications of percents, we're going to look at one more, which is something that probably everybody here will deal with at some point, and that's called simple interest. And to see what simple interest is, we need to look at an application of the percent equation specifically. So I'm going to ask you to go ahead, pause the video, and see what you can do with this problem here. The scenario being that you deposit $250 in a savings account, something that probably everybody in the class will have at some point in their life if you don't already. And then often with savings accounts, you earn this thing called interest, which is extra money that gets paid to you just for having money in the account. So in this one, which is a really large amount of interest for an account, but for the sake of the problems, we're going to have some high interest rates. So let's imagine that every year you earn 2.5% of that money extra. So the question is, after 1 year, how much additional money will you have if you earn 2.5% of your initial deposit? So go ahead and pause the video, see what you can do with this problem, and come back when you're ready. Please use the percent equation, not the percent proportions, but the percent equation itself to solve it, as that setup is going to be important in the future. So here, what we're looking at is that we're taking a percent, this 2.5%, and in our percent equation, that's going to go with P, obviously, because that is the percentage rate. But remember, we're not going to plug 2.5 there. We need to use the decimal form of the percent. And in order to turn 2.5% into a decimal, we move the decimal point over 2 spaces. So our P becomes 0.025. And now for the $250 in the savings account, that is what we are actually taking the percent of. That's where we're finding 2.5% of. So therefore, it becomes the base. And this extra money that we earn, which we'll keep calling A, is just going to be the product of 0.025 and 250. So once you've gone through and multiplied that out, you should end up with an A equals $6.25. So if you put $250 in the savings account and you have 2.5% interest, which, as I said, is an enormous amount of interest for an actual savings account, but for the sake of the problems, we're going to have some larger numbers here to make the calculation slightly easier as we're practicing. After 1 year, you would earn $6.25. Now see what you can do with the next problem that we have, which is looking at that same scenario and asking how much additional money will you earn after 2 years. Now there are 2 ways to do it, one very straightforward and another using the percent equation. Obviously you can use the straightforward version to see what your answer should be, but see if you can modify that percent equation a little bit and get the answer that you're looking for about how much additional money you earn after 2 years. So go ahead, pause the video, work on this, and come back when you are ready to move on. So the most direct way is to say, well, in our last problem we said with this idea that you would earn $6.25 in 1 year, so we should, as a matter of checking, say that $6.25 times 2, because $6.25 for each year is $12.50. So after 2 years, we should earn $12.50. It's important here because it says you earn an extra 2.5% of your initial deposit, is that it's still the $250 every time. So that's the quick version of it. You can just take your answer and multiply it by 2. But let's see what we can do with the percent equation there. So again, our percent equation is A equals P times B. We said that our percent, the 2.5%, was 0.025, because that's 2.5% in decimal form. Our base is still 250. And we still don't know necessarily, although we do know now because we've done it before, we still don't necessarily know how much money we're going to earn. Now this is what we get for 1 year. So if this happens every year, then one of the ways we can adjust for 2 years is to say, okay, well if this is 1 year, let's just multiply that whole thing by 2. And if we find out our 1 year's total and we multiply it by 2, we should have our 2 years total. And in this case, if you multiplied that all out, you would get, in fact, that you would earn $12.50. So we can either go straight to it by multiplying our product that we know by 2, or we can tack on a 2 to the end of this percent equation, because each time we do 0.025 times 250, that represents 1 year. Multiply it by 2, we should get 2 years. Another problem for you to look at, what do you think you can do with this? The question now, same scenario, how much money will you earn after 5 years? Go ahead, pause the video, come back when you are ready to move on. So again, you can either multiply 625 by 5, or if we went at it from the idea of the percent equation, 2.5% again, 250 as our base, and since we're talking about 5 years, we would multiply everything by 5. So still the same thing that we looked at before. That's our initial percent equation for 1 year, and since we're talking about 5 years, we can just multiply that product by 5 to get what would happen after 5 years. And $6.25 times 5 is $31.25 after 5 years. And so now we can imagine that this can happen over 3 years, 4 years, 10 years, 20 years, and if we know the number of years, we can find out how much money this savings account will earn. But the big question that we can ask is, what if we just have this generic T years? We know it's been sitting around for a number of years. How will we find out, or how will we give a more generic formula to how we can find out how much money we would earn after T years? So pause the video, see what you can do with this, and when you come back, we'll look at what this has to do with simple interest. So you might have said that we just do 625 times T, which is true because 625 is 1 year, and if it's after T years. But if we use that percent equation with A equals P times B, then A is the amount of money that we earn. Our percent is this 2.5%, which in this case is 0.025. The base in this case was 250. And we just take this, which represents 1 year, and we multiply it by however many years we're talking about. So it's our basic percent equation just multiplied by the amount of time. And this formula here, without the specific numbers plugged in, is what we use to find what's called simple interest. And before we do that, we have to define a few things so that we know what they mean. First is that if you earn interest or if you pay interest, interest itself is just the amount of money paid, is an amount paid for the use of money. So you deposit money in a savings account, then the bank pays you interest because you have given them the money to keep in that savings account. The amount of money that you actually deposit is called the principal. The opposite is true. There's still called principal and interest. But if you, for example, borrow money to buy a car, borrow money to buy a house, borrow money for student loans to go to school, that amount of money that you borrow is called the principal. And then instead of being paid interest, you pay a little bit of extra interest every year because you are using someone else's money. You're borrowing someone else's money. And if the interest is paid only on that percent, only on the money that you borrowed or the money that you deposited, we call it simple interest. So in that last example where you only earned interest on that $250 and not on whatever you earned every year, that makes it simple interest. There is another type of interest called compound interest that you'll learn about in pre-algebra. But in this case, we're talking about simple interest. So if we looked at it from the point of view of the percent equation, A equals P times B, P was still our percent, but it's hard to say, it's hard to call it something that's a percent, and something like 2.5%, we have another word for it. That's called our rate, our percentage rate. So let's call it R for rate. B, as the base, was the amount of money that we put into the savings account, so it was the principal. So the principal is the base. Let's call that P for principal, and often principal has a capital P. And then we adjusted for it by saying, well, this happened over a certain number of years, so this is the adjustment for time. And when we multiplied all of this together, we found the amount of money that we earned, for example, after 1 year, after 1 year, after 2 years, after 5 years, etc. And that was simple interest. So we found our interest by multiplying our principal times whatever rate it was and then adjusting for time. And if we use this equation right here, that is called the simple interest formula. And it says the amount of interest that's earned on an amount of money, the principal either borrowed or deposited, is that amount of principal times the rate, the interest rate, that's the percentage rate, and then adjusted for the number of years. Now, time can be in months, it can be in days, it can be whatever the rate is in, but usually it's years. And we call it a rate rather than a percent because when we're looking at that 2.5%, it's not just 2.5%, it's 2.5% per year. So now that we're comparing a percent to an amount of time, it becomes a rate like we talked about when we were going over ratios or rates. So this formula is what we're going to use for simple interest. Interest equals principal times rate times time. So I'm going to give you an example problem that goes through it that I'll take you through, and then we'll have 4 problems after that for you to work on your own. So in this example, if you borrow $2,500 at 3% simple interest for 4 years, how much interest will you pay? Well, the simple interest formula that we should always write down is I equals PRT. Here, you borrow $2,500, so that's the principal. Our interest rate is 3%, but again, it's going into a percent equation, so it has to become its decimal form, which is 0.03, and you borrow it for 4 years, which is the time. So when we're asking how much interest do we earn, we don't know what I is. And if we went through and did this calculation, we'd find out how much interest we would earn over 4 years. So 2,500 times 0.03 times 4 is $300. So you would have to pay $300 in interest over 4 years. Here we don't have to multiply this by 4 because we've already adjusted it by 4 in our formula. So that's the idea. You identify what each of the numbers mean, plug them into the formula, and either calculate or solve depending on what you have. So go ahead, pause the video, remembering that our simple interest formula is I equals PRT, and come back when you're ready to move on and find out what the answer to this problem is. So here it says you deposit $3,200. That means $3,200 is your principal. Pays 1% simple interest, which means that the interest rate is 0.01. And you want to know how much interest you'll earn after 10 years. So 10 years is our time. So our interest is going to be the same as 3,200 times 0.01 times 10. And in this case, if this were what you were earning, after 10 years, you would earn $320 in interest, because that's 3,200 times 0.01 times 10. Moving on to the next problem, see what you can do here, remembering that our formula is I equals PRT. Here we have a different unknown, so it's just a matter of figuring out what each number means, plugging them into the formula, and solving the equation that you get. So go ahead, pause the video, and come back when you're ready to look at this. So here, it says that after 4 years, we've earned $480 of simple interest. So that $480 is going to be our I. It says we've learned if we've done that after 4 years. So 4 is our T, and that the interest rate is 2%. So the R is 0.02. And since it's asking how much money did you deposit, we don't know what our initial deposit or our principal is. So now we have an equation with an unknown that we can solve. This is 4,800 is equal to P times 0.08, because that's 0.02 times 4, divided by 0.08, being sure to show the work that balances the equation. And we end up with the principal is the same as 480 divided by 0.08. Doing out that calculation gives us $6,000. So we initially deposited $6,000. So here's our next problem. Go ahead, pause the video, see what you can do. Come back when you are ready to go through the answer. Again, our simple interest formula is I equals PRT. It says you owe $10,000 in interest. That's not what you deposited. It's $10,000 in interest. After 8 years, so we know that our time is 8. You borrowed at a rate of 5%. Which means our rate is 0.05 because we have to use the decimal form, and what we don't know is our principal. So here, much like our last one, we have interest that we know, but our principal that we don't. So multiplying 0.05 times 0.8 together, we get 10,000 equals 0.4p, divide by 0.4, and we find that we borrowed initially $25,000. So we borrowed $25,000, and after 8 years, paid $10,000 in interest at a rate of 5%. Last problem, go ahead, pause the video, see what you can do. So again, our simple interest formula is I equals PRT. You deposited $450 in savings accounts, so therefore our principal is $450. You earn $180 in interest, so therefore $180 is our I on its own end of the equation, and you've done it for 4 years. So what you don't know, in fact, is the rate. So now we're going to have to solve for the rate. 450 times 4 is going to give us 180 is 1,800 times R, divide by 1,800, and we get 0.1 or 1/10 equals R. So does that mean our percentage rate is 0.1%? No, remember our rate is always in the decimal form, so to change it to a percentage form, we just move the decimal point over 2 places. So the rate is an astonishing 10% interest. So again, the simple interest formula, interest equals principal times rate times time, is just an application of our percent equation, but in this case we're talking about money that's borrowed or deposited, some interest that we're paying, but it's simple interest because it's on the principal only. So that formula again, I equals PRT.